Let's find the volume of the solid of revolution created by rotating this region around the x-axis. In order to create a washer, we are going to use a vertical integration element. So this vertical integration element, it's like a thin little rectangle. When it rotates around the x-axis, it creates a washer. And the inner radius of that washer will be given by this distance. And the outer radius of this washer will be given by that distance. So let's go ahead and figure out what we have there. So we'll have pi. The area of a washer is pi times the outer radius squared minus the inner radius squared. So we are going to square this outer radius, subtract off the square of the inner radius. We'll simplify this a little bit. 32 squared, we'll figure that out in a minute, multiplied by x minus 64x squared. So there is the area of the washer. We now are going to integrate that for x equals 0 to whatever that intersection point is right here. So let's go ahead and figure that out by setting the curves equal to each other. So we're going to have 32 square root of x equal to 8x. We can divide out the 8. 8 divides into 32 4 times. We have that. We have a square root, so we will square both sides. That will give us this equation. And then we'll move everything to one side and factor. So we'll have x squared minus 16x is equal to 0. The x can factor to the front, leaving us this product. And the zero product rule tells us that x will be 0 or 16. That tells us that these two intersection points are 0 and 16. All right, so those will be our limits of integration. In order to find volume, we are going to integrate area. So we will be integrating the area on the interval from 0 to 16. Pi can come out to the front. We can move it out to the front now. We'll move it out in a minute. Doesn't matter. And so then we're going to have this 32 squared x minus 64x squared dx. This will give us pi out in front. And let's just leave the constants in there for a minute. So we are going to end up with 32 squared. We add 1 to this exponent, divide by the new exponent. Similarly over here, we'll have 64. We're going to add 1 to the exponent, divide by the new exponent. And then our limits of integration will be 0 and 16. So plugging and chugging here. The 0 is not going to be a contributor. So our 16 gets plugged into that x. That's going to give us 16 squared, which is 256. This is all divided by 2, minus 64 multiplied by 16 cubed, all divided by 3. Let's see if we can kind of combine some of this stuff and simplify it. With a little bit of arithmetic here, we will end up with the following. So that will be our final answer after a little bit of arithmetic there. That will be the volume of the solid that is created by rotating that region around the x-axis.